Um, okay. After class, actually, some people ask me about Professor. How about if for um for the question two, which is we have metal with positive seebeck coefficient, but only 2 microvolt per K. How about if I switch the temperature distribution here with T2 larger than T1? Then how to will the F capital Q changes? So I simply just give you like write down this results as an example, show you. I still keep the battery with the same directions and only switch the temperature, which means to allow T1 lower than T2. So when you write down the heat flow, it's a kappa T negative temperature gradient divided by T and plus low ST negative electrical potential gradient. But here, if you take the temperature gradient here, and because it's a temperature gradient here is 310 to 4, right? But we use this T2 to minus T1 and have a negative on it. So here will be this times this, and we have a negative on it. So here will be a negative. But some people curious about why it's not positive. But I just remind you, the gradient term is depending on how you define your coordinate. The here inside in this case, the gradient actually, because I sent to right-handed side, this is a positive term. So the gradient actually is a slope between this. So temperature gradient actually is a T2 minus T1 and is positive, and we have a negative term. So this term tells us that the heat flow induced by temperature gradient is go to left-handed side, is negative, go to left-handed side. So you double check whether your assumption or your settings is correct, right? Because for this case, heat flow should be go to left-handed side, which induced by temperature gradient. Okay, so you can double check with if you like mess everything up. So first thing is remember the gradient term actually will be depending on where you sent, which direction you sent for your positive. So in here I sent it go to right-handed side is positive. So gradient actually is a slope for those two conditions. So slope is this minus this one. Okay. So if the T2 is lower, so you use this 2 minus this one and have a positive term on it, and you will get the heat flow go to right-handed side. Everything is perfect. And you also can do the same thing here to check whether you mess everything up. F small q is the battery you connect here. And I also draw the, due to like this is positive, or this is anode, this is cathode. So I phi 1, phi 2, and gradient actually is a slope here. So we use a phi 2 minus phi 1 and have a negative term here. Phi 2 minus phi 1 is negative times negative, so we have positive. Positive means that the current actually is go to right-handed side. It is correct as you expected, right? Because you connect to battery have higher electrical potential here will drive the current go to right-handed side will be correct. Okay, so for your reference, hope you have some idea here. So, okay,